Hello students, welcome to Namoni. This is Ravikant, your Physics teacher, and today we are going to discuss about laws of motion part 3. Before that, I want to know whether you all have seen the video 1 and video 2 of laws of motion, and please let me know it in the comment. And if you have seen it, let me know how much you have understood and how much you have practiced the questions. For your practice, we also provide you a book of PYQ. PYQ provided by One Memory. Please go and practice some questions from that book because the questions in that book are arranged and being given in such a manner that it will enhance your understanding for the numericals and approach for the numericals. The explanation in that book for every numerical is such a way that it will make very clear for you how the numericals will be solved, explaining each and every step, right? Understanding each and every step. So please go for this PYQ book, and a dropper batch is being announced by Memoni for the students who have dropped. So you can go and check that in the Memoni app. If you have not downloaded it, please download Memoni app and you can check each and everything there, and also can order your PYQ book from there, right? So if you have seen my last two videos, then this video is the continuation of those two videos. And if you have not seen, please go and watch that video, like it, share it, and comment so that more other people can understand the concept of laws of motion. Now today we are going to understand about the equilibrium of concurrent forces, right? Now the equilibrium of concurrent forces. The concurrent forces means the forces are acting at the same point, right? The same point all the forces are acting, right? Like this, and this, which is being shown in the figure. Now what the figure shows that there are three forces F1, F2, and F3. That will be F1, and this is F2, and this is F3. They are acting at some angle with each other. So between F2 and F3 it is gamma. Between F between F1 and F2 it's gamma. Between F2 and F3 it's alpha. And between F1 and F3 it's beta. Right? So they are in equilibrium. Equilibrium means that the sum of all the forces acting on the body is equals to 0. That is F1 plus F2 plus F3 is equals to 0, right? This is what equilibrium means. That is the F net on the body is 0. And when this is the case, suppose this is the case, that is the forces are acting in such a manner that they are acting on the same point and they are at angle with each other, and the body is in equilibrium, then we can write an equation which is F1 upon sine alpha. Alpha is the angle between F2 and F3. This is equals to F2 upon sine beta. Why beta? Because we are writing about a numerator F2, so the angle between F3 and F1. This is equals to F3 upon now sine of angle between F2 and F1, which is gamma. If we remember this, that F1, F2, and F3 are concurrent forces and they are in equilibrium, or they form a system of equilibrium, then we can solve our question using this equation, right? Now, let's get into the numerical for such kind of questions or the numericals related to concurrent forces. Let's see the first numerical. The numerical says the mass of 6 kg is suspended by a rope of length 2 meters from a ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint of the rope as shown in the figure. The figure you have to draw. Now, what is the angle the rope makes with the vertical in equilibrium? Taking g is equal to 10 meter per second but neglecting mass of the rope. So, see what is given in the question is suppose this is a ceiling and a mass of 6 kg was suspended. Now there is a force which is acting in the horizontal direction at the midpoint of the rope. The force applied is 50 Newton. The length of the rope was 2 meters, so this will be 1 meter, and below this will be 1 meter, right? So when this force has been applied, what will happen? This system will take shape like this. It could be something like this, right? This will be the body. This is the 50 Newton force, and there will be a tension in the string, let's say T, and this rope is making an angle theta with the vertical. Now, how to solve it? See, if we look at this point, there are three forces acting on it. One towards right, which is 50 Newton, another at this angle, that is tension T, and third is in downward direction, which is the weight of the body, which is 60 Newton. Why 60 Newton? Because mass is 6 and acceleration due to gravity is to be taken as 10. So 60 Newton in the downward direction. So if I redraw this, this is T, this is 50, and this is how much? This is 60, right? Now what they are saying that this angle is equal to theta. So if I draw a vertical line like this, then this angle will also be equal to theta, because this and this are parallel to each other. So being an alternate angle, this will be equal to theta. If I resolve this vector, it will be resolved in two vectors, one along the vertical axis and another along the horizontal axis. Now just for your understanding, I am redrawing it. This is T Newton, this is 60 Newton, right? And this was T, which is now resolved in, and this was theta, right? So this is resolved in T cos theta, and this is T sin theta. So now finally what we are left with is, here it is 50 Newton, here it is 60 Newton, here it is T cos theta, and here it is T sin theta. And the system is in equilibrium. It means the net forces are zero. So if I calculate the net force in x-axis, right? So F along x-axis, right? This will be equals to 50 minus T minus T sin theta, right? And this has to be equals to 0. So 0 is equals to 50 minus T sin theta. So from here we can write T sin theta is equals to 50, right? Similarly, if we look into y-axis, these two forces are in opposite direction and the net force in y-axis is supposed to be 0. This is only when this t cos theta is equals to 60. So I am directly writing it as uh, t cos theta is equals to 60. Now dividing these two equations, what we get? We get tan theta is equals to 5 upon 6. So we can say theta is equals to tan inverse 5 by 6. In the question they asked us about the angle. They want the angle. What is the angle the rope makes with the vertical in equilibrium? So the angle the rope makes with the vertical in equilibrium is theta is equals to tan inverse 5 by 6. So this is the angle the rope. So here what we have used is, we have used the concept of resolving the vector, which I told in the first video itself that you need to practice for this. If you do not, if you are not clear with the concept, go and get it cleared, and you should know how to resolve the vector, because this will help you to solve the numerator. So by resolving the vector, that is the tension force, and applying with the system with an equilibrium, we finally calculate the angle which the roof makes with the vertical. Right? Now let's see one more numerical. In this numerical, it says a ball of mass 1 kg hanging in equilibrium from two strings OA and OB as shown in the figure. What are the tensions in the string OA and OB taking G is equals to 10 meter per second? So we can see the diagram. This is the point, concurrent point, the point at which the forces are acting. The ball has a mass of 1 kg, so its weight will be equals to 10 Newton, which will be acting downwards. In one of the string, the tension is T2, and in another string it is T1, right? The angles at which they are inclined with the horizontal is being given to us, right? So again, we have these angles. So this is if you look into the triangle AOB, it's 30 plus 60 is 90. So this angle comes out to be 90. This is 150 and this is 120. This has been given in the question. So because these are three different forces acting at the same point and the system is in equilibrium, then we can use the Lami's law, that is which we saw in the beginning, that is your 10 Newton upon angle between the rest two forces is 90. So we'll write as sine 90 is equals to, now the next force, let it be T1. So T1 upon, now the sine of angle between T2 and 10 Newton, which is equals to 150. This is equals to T2 upon sine of angle between the rest of the two, that is 120 degrees. So this can be written as 10, because sine 90 is 1, T1 upon sine 150 can be written as sine 30 is equals to sine T2 upon sine 120 can be written as sine 60, right? So from here we can say 10 is equals to T1 upon 1 by 2. This implies that 10 is equals to 2 times of T1. This implies that T1 is equals to 5, right? So we got T1. Again from there itself we can say that 10 is equals to T2 upon sine 60 is root 3 by 2. So from here we can say that 10 is equals to 2 T2 upon root 3. So from here we get T2 is equals to 5 root 3 Newton, right? So we got the value of T2, we got the value of T1. What they are asking is, what are the tensions in OA and OB? So T1 is in OA, so this is for OA, this is for OA, and this is for OB, right? So using the Lami's theorem, Lami's law, which we have seen in the beginning of the lecture, is we got the value of T1 and T2, right? Now let's see how to draw the free body diagram for a given scenario. Now suppose this is a scenario given to us. I need to calculate some value, let's say A or T from this. For that, what we'll do, we'll draw the free body diagram and write the equations and solve it. Let's see how. See, uh, this is, let this be the body with a mass capital M, and this another body of mass capital 2. These two bodies are tied with a string, and the string is passing through the pulley, right? Now the system is accelerating in this way. That is, small m is moving upward and capital M is moving downward. Now what we are supposed to do is we are supposed to draw the free body diagram for the two bodies involved over here. There are two bodies involved over here. So let me draw the first body. The very first body which we are going to see is the body capital M. Now what all forces are acting on it? There is one force which is acting downwards, which is the weight of the body, that is M into G. Another force is acting in the upward direction, which is tension. And in spite of all these two forces, the body is not in equilibrium. It is moving in a downward direction with an acceleration A. So for this scenario, what we will write is the equation C. M1G is in downward direction, T is in the upward direction, and still the body is moving in the downward direction. It means that Mg is greater than T. Mg is greater than T. So what I can write is Mg minus T is equals to M into A. Right? This is what is happening. Understand it well. If I give you an example, suppose V in the downward direction it is 10 Newton, and in the upward direction it is, let's say, 8 Newton. So the body will be moving downwards because of the force of 2 Newton, which is the resultant of these two forces, right? So this 2 Newton is nothing but mass of the body into acceleration. So if the mass of the body is, let's say, 1 kilogram, the acceleration in the downward direction will be A will be equal to 2 meter per second square. So using this concept, we can write this equation, that is mg minus t. These are the two forces acting on the body, among which mg is greater. So the body is moving in the direction of mg, and hence it is having an acceleration of A. So the force experienced by the system will be m into A. Now let's look for the sorry, let's draw the free body diagram for the second body. Now the second body is of mass small m. Now what all forces are acting on it? Force acting on it is in the downward direction, it is m into G. In the upward direction, again there is a tension T, and in spite of these two forces, the body is not in equilibrium, it is moving in the upward direction with acceleration A. So what we can say here, T is greater than mg. So what we will write T minus mg is equals to m into A. Right? T minus mg is equals to m into A. Now these are the two equations. These are the two equations. Now if m, the masses of the bodies are being given, we have only two variables, that is T and A. Now there are two variables and two equations, we can solve simultaneously and get the value, right? So this is how we draw the free body diagram. What the free body diagram means is that we are removing the body from the system and drawing all the forces acting on it, and on the basis of the direction of the forces, we are writing the equation, and with the help of the equation, we will try to find the unknown value, right? This is what is free body diagram. To understand it well, we'll solve some numericals. Let's see this numerical, that a pull of 50 Newton is applied to a rope attached to a block of mass 7 kg lying on a smooth horizontal surface. The mass of the rope is 0.5 kg. What is the force exerted by the block on the rope? Okay, so this is a horizontal surface. There is a block on it, and the block is of 7 kg. And with the help of a rope, we are pulling it, applying a force of 15 Newton. Now, when with the help of a rope we are pulling it, and rope is nothing but a string, there will be a tension in the string, and we draw the tension like this, right? So, a pull of 15 Newton is applied on the rope attached to the block of mass 7 kg is lying on a smooth horizontal surface. If it is lying on a smooth horizontal surface, then definitely it will start moving, and the acceleration in the body will be in this direction, right? Surface. So, the mass of the rope is 0.5 kg. So, if force applied is 15 Newton, right, and mass of the system is equal to 7 plus 0.5, So it will be equals to 7.5 kg. 7 is the mass of the block and 0.5 is the mass of the rope. So the net acceleration experienced by the system will be equal to 15 upon 7.5 is equal to 2 meter per second square. Right? This is the acceleration A. This A is equal to 2 meter per second square. What they are asking is the force exerted by the block on the rope. Right? Now see, this tension T is an internal force and it can be drawn in both directions, in this direction and in this direction. Right? So if I redraw this 15 Newton is the force which the rope is acting on the block, then this tension T will be the force which the rope is acting on the block, right? So if I write the equation for the rope, if this is the rope, we have a force of 15 Newton acting in this direction and a tension T acting in this direction and there is an acceleration A, right? So 15 minus T is equals to 0.5 into A. So from here you will get 15 minus T is equals to 0.5 into 2, which will be 15 minus 1 is equals to T. So we will get T is equals to 14 Newton, right? Now if T in this direction is 14, so this direction will also be 14. So our answer for the force exerted by the block on the rope will be equals to 14 Newton, right? So what I have done is I have drawn a free body diagram of the rope. On the rope, a force of 15 Newton is acted in this direction, and because of this 15 Newton, there is a tension on the rope in this direction. So because in spite of these two forces, the rope is moving in this direction with an acceleration A. So this is the equation which matches the scenario. Putting the values and solving, we get T is equals to 14 Newton, and T is nothing but the force exerted by the block on the rope. Right? Let's see the next numerical. This will give you more clarity. The next numerical says that a body M1 of mass 10 kg is placed on a smooth horizontal table. It is connected to a string which passes over a frictionless pulley and carries at the other end a body M2 of mass 5 kg. Now, what acceleration will be produced in the body when the nail fixed on the table is removed? What will be the tension in the string during the motion of the body, and what when the body stops? Taking g is equal to 9.8. So let's understand the scenario by drawing the diagram. See, uh, this is a table. Let's say this is a table, and here there is a pulley. Here is one of the mass which is of 10 kg. A string passing over the pulley. At the other end, another mass of 5 kg. Now there is a nail over here. As per the question, there is a nail over here which stops this block to move, and as the nail is being removed, the block moves in this direction with an acceleration A. With an acceleration A, right? So if I draw the free body diagram for the two blocks, this is 10, right? Now if this is the case, there will be the weight acting over in this direction, because of which there will be a tension in the string P, and because the string is same, there will be a tension here also P, right? So if the string is same, the tension in the entire string remains the same. So as per this, if I draw the free body diagram, this is P which is acting on the body 10 gram of 10 kilogram, and here it is an acceleration of A, right? If we talk about the vertical axis is the normal reaction force and the weight of the body, which gets cancelled out and is not required over here because the body is moving in the horizontal direction. If we talk about the horizontal direction, we can say from here this for free body diagram that T is equals to 10A. T is equals to 10A. And for the 5 kilogram body, in this direction it is 5 into 9.8, and in the upward direction it experiences tension T, and still it is moving in a direction, in a downward direction with acceleration A. So from here we can say, so 49, that is this 5 into 9.8 is 49, minus T is equals to 5A. Now if I put this value of T here, we will get 49 minus 10A is equals to 5A, right? So we'll get 49 is equals to 15A. So A is equals to 15 upon 49 meter per second square. Now once we have A with us, putting the value of A here, we will get T, and then T will be equals to your 150 upon 49 Newton, right? Yes, T will be equals to 150 upon 49 Newton. So again we have drawn the free body diagram for the two bodies and written the equation, and then solving them we get the tension and the acceleration in the body. So what they are asking is what will be the tension in the string during the motion. So during the motion this is the tension in the string. Now they are asking you what when the body is stopped. When the body is stopped, it means when body is at rest, they are not moving, then this will be the case. This is 10, passes over a pulley. This is 5, and 49 Newton is acting in the downward direction, and tension T is acting in the upward direction. So here acceleration is equals to 0, but tension T will be equals to 49 Newton, right? So the tension T will be equals to 49 Newton when the body is stopped. The bodies are not moving, right? Let's see one more numerical. These numericals are just to understand the free body diagram and how to apply the laws of motion. That is, if the net force is acting on the body is 0, then the sum of all the forces will be equal to 0. And if it is not equal to 0, then we have to make the balance of the forces by resolving the answer. Now here it says that two blocks of mass 50 kg and 30 kg connected by a massless string pass over a light frictionless pulley and rest on two smooth planes inclined at an angle of 30 and 60 degrees respectively with the horizontal. Right? Determine the acceleration of the two blocks and tension in the string, taking g is equals to 10 meter per second. So to understand this, let's draw the diagram. This is horizontal and this is 30 degrees and this is 60 degree, 60-degree inclined, right? This is 60 degree and this is 30 degree. There is a pulley here, two bodies. This is of 50 kilograms and another body. This is of 30 kilogram, they are attached with the string, right? So they are asking the acceleration and tension in the string. So this, let's say that this system is accelerating in this direction. Okay, this is how they are accelerating, right? So if I redraw this, here it is 50, and here it is 30 kilogram. This is moving in this direction. Let's say acceleration. Let's take acceleration in this direction. A. This is A. Tension will be T, and then again tension will be P. Right? If this is 30 degrees and this is 60 degrees, then see how it will be done. The weight of the body will be acting in this direction downward mg. Now I have resolved this mg along the inclined plane and perpendicular to the inclined plane. So if this is theta, if this theta is equals to 30 degrees, then this angle will also be equal to 30 degrees. And if this angle is 30 degrees, this force will be equals to mg cos 30, and this will be equals to mg sin 30, right? That is m over here is 50, so it will be equals to 50 into 10, that is mg, into sin 30, right? Similarly here, this weight will be acting downwards. This can be resolved in two directions, one perpendicular to the plane, another along the plane. This angle will also be equal to 60 because this angle is equal to 60. If this is 60, this will be equal to 30 into g into sin 60, and this will be equal to 30 into 10 into cos 60, right? So now if I draw the free body diagram for, let's say, first 50 kilogram body. So for 50 kilogram body, this is the force along the inclined plane, which is equals to 50 into the 500 into sine 30, that is 1 by 2, which is equals to 250 Newton, right? In this direction we are having 250 Newton. This is for 50 kg body, and in this direction we have tension P, and the acceleration is in this direction K. So the equation will be equal to T minus 250, because T is dominating over here. So T minus 250 is equal to 50A. Let this be the first equation. Now for 30 kg, again in this direction is the tension acting on the body, and in this direction is your mg sin 60. Sin 60 is root 3 by 2, which is equals to 150 root 3 Newton, right? So from here, and still the body is accelerating in this direction A. So we can say that 150 root 3 minus T is equals to 30 into A. Now what we should see here is this 150 root 3 is less than 250, right? So definitely the direction of the acceleration will be opposite, right? So changing the direction and again writing the equation, this is for 50, this tension will be in this direction, in this direction it will be 250 and the acceleration will be in this direction A. So the equation will become 250 minus T is equals to 50A, right? I hope there is no confusion. Now for 30 in this direction it is 150 root 3 Newton. In this direction it is tension T and the body is moving in this direction A. So we will write T minus 150 root 3 is equals to T A, right? Now let this be equation 2. Now if we add equation 1 and equation 2, adding 1 and 2, what we'll get is 250 minus T is equals to 50A and plus T minus 150 root 3 is equals to 30A. Adding this will cancel out. What we are left with is 250 minus 150 root 3 is equals to 80A, right? Putting the value of root 3 over here and calculating, we'll get acceleration A, right? We'll get acceleration A because here only acceleration A is the variable. And once we get acceleration A, and if we put in this or equation 1 or equation 2, we'll get the value of tension as well, right? We'll get the value of tension as well. I leave the part of calculation for you all, but I hope the concept for writing the equation from the free body diagram is clear to everyone. That how to draw the free body diagram and how to write the equation for from the free body diagram to get the value, right? So this is how this numerical will be solved. So today in this video, what we have studied is how to handle the concurrent forces in equilibrium and how to handle the case when two bodies are connected with each other and to find the tension in the string and to draw the free body diagram and write the equation. This is all that we have studied from this video. So I request you all to go through the video, understand the concept, practice more and more questions so that the concepts are clear. And if you have any doubt, please let me know in the comment box. And also if you find that I have missed something or some concept is not clear to you, please let me know in the comment box itself and I will try to resolve each and every problem of yours, right? Also, please subscribe and like this video, subscribe the channel and share as many videos as you can, right? So, ending up with this, I request you all to practice the questions because without practice, these questions will not be easy for you all. So, more is the practice, more easier will be more easy it will be for you to understand the concept, right? This is all from my side for today. Thank you and good luck for your BTS 7.